Okay, 12.1 is about sequencing and series. Okay, sequencing and series. So here's the deal. For 12.1, we are going to start with, that's what we're on, yes, 12.1. Sequencing and series. Okay, remember like when you were a kid and they would like give you like 2, 4, 6, 8, and they'd be like, what's the pattern? Okay, and you would tell me like they're counting by twos or whatever. That's what we're doing, just on a little bit of a deeper level. So 12.1 is defining and using sequences and series. Okay, and there are patterns and formulas to stuff we're going to do. Okay, a sequence is a function whose domain is a set of consecutive integers. A sequence is a function whose domain, and domain is what values usually?
All real numbers. Wait,
No.
oh, X values, my bad.
Yeah, it's like what's the x values, or
Oh,
what,
my bad.
what my inputs are. Set of consecutive integers. Okay, consecutive integers. And then, if a domain is not specified, it is understood that the domain starts with 1. So if it doesn't tell you where the starting point is, you're starting with 1. Okay? If it doesn't say, hey, this sequence starts at 6 and continues in this format, then you know that the sequence just starts at 1 automatically. Okay? The values of the range are called the terms. So the domain is my sequence, it's my input, and the values that I get are called my are called terms, which are my range. So let's say your domain looks like this. 1, 2, 3, 4, so on and so forth. Okay? And let's say that your output, okay, they're saying is A1, A2, A3, A4. Okay? So you're gonna have an input and an output, a domain and a range on sequences. Okay? A finite, there are 2 different types of sequences. There's a finite sequence and an infinite sequence. Finite looks like this. 2, 4, 6, 8. Infinite looks like this. 2, 4, 6, 8. What's the difference?
That has like extra dots. Or
Yes, the extra dot means, so an infinite, common sense here, means that this sequence is going to continue forever. A finite sequence has a stopping point. That's the only difference, okay? So they could be the same type of sequences happening, but one's finite because it stops at a specific point, one's infinite because it can continue on forever. Okay? That's the only difference. So then we're gonna get problems that look like this. Let's say, write the first 6 terms, okay? Write the first 6 terms of, and it says A n equals 2n plus 5. So this is example A. And then B would be a n equals, or f n, whatever, it doesn't matter. Function of n equals -3 to the n minus 1. Okay? One's the first 6 terms. So how would I even do that? What would I do? First 6 terms for that first part where it says a n equals 2n plus 5. What do I start with?
1.
1, because it didn't tell me specifically, so I start with 1. So here's what this looks like when I set it up. A of 1 equals 2 times 1 plus 5. So that would equal 7.
7, yeah.
A of 2 equals 2 times 2 plus 5. So that would equal 9. A of 3, see how the n is my term that I'm using, okay? Equals 2 times 3 plus 5. 13, yes? A of 4.
Wait, isn't that 11?
Oh, it is 11. 5 plus, yeah, 8. 5 plus 6. I was doing 8 in my head for some reason. 2 times 4 plus 5. 13. A of 5. 2 times 5 plus 5. Okay, and A of 6. 2 times 6 plus 5 equals 17, yes?
So, because you knew that it was gonna be odd numbers from 7, you could just like,
You could just say A of 1 is 7, A of 2 is 9, A of
Yeah.
3 is 11, yeah. You don't have to show me the work once you pick up on the pattern. If you're not picking up on the pattern, show me the work,
okay.
okay? So, those are my first 6 terms, which is what I asked for, okay? It didn't give me a starting point, so I start at 1, and I literally plug 1 into both ends, and it tells me what term. So here, what am I gonna start with? 1, and I get this. What's 1 minus 1?
0.
Anything to the 0 power is?
1.
What is 2 minus 1?
1.
And that would give me negative 3 then, yes? F of 3. What's 3 minus 1?
2.
So negative 3 squared is?
No, it's
9,
It's a
positive
it's a
9.
plus.
F of 4 would equal, what's 4 minus 1?
3.
And what is negative 3 cubed?
27.
How about negative
Oh, yeah, because it's
27?
Yeah.
F of 5, so what's the pattern here?
When
It's
it's-
negative. It's switching back.
When
It's switching back and forth, right? So 5 minus 1 is 4, what's negative 3 to the 4th?
I think 81.
I think 81 also, yes. And then I have F of 6, which is negative 3, and it's 6 minus 1, so negative 3 to the 5th. So negative 243.
Yep.
Okay? So that first part shouldn't be too difficult. You should be able to do that and figure out stuff by just plugging in numbers. If they tell you to start at 12 and give me the next 6 terms, start at 12 and give me the next 6 terms. If they don't tell you where to start, you start at 1. Cool? Okay. The next part is describing patterns and writing an equation off of that. Like writing this so that I can figure out what the pattern is. Okay? This circuit's a little bit trickier. Okay? It says describe the pattern.
Don't die.
Write the next term.
Yeah.
What's wrong, Drew?
No,
Okay. Write the rule. So there's a lot of directions here. Write the rule for the nth term of the sequence. And the sequence for A is negative 1, negative 8, negative 27, negative 64. Let's start there. What can we recognize about these things? Now, remember, what do you start with if it doesn't tell you?
1.
1, okay? So when I input 1, I get that out. When I input 2, I get that out. When I input 3, I get that out. And when I input 4, I get
Oh, I see.
that out.
I see.
So what do you think the pattern is?
What's that part?
It's exponents, okay? So tell me what that means. What are you noticing?
If it's to the 1 power, then I guess
Okay, let's look past 1 real quick, because sometimes 1 doesn't tell us a lot. How do I get 2 to negative 8?
2 to the negative third.
Well, if I did,
2 to the negative.
you're on the right path, okay? You were saying 2 cubed is 8, right?
Yes.
2 times 2 times 2 is 8, okay? So what cubed gives me negative 8?
Negative 2.
Negative 2. So this number should be
Oh, negative.
negative. And so that means that all of these probably are negative. So we start with 1 and we work from there to manipulate. Does that make sense? So my pattern is this, okay? Negative 1 cubed gives me negative 1. Negative 2 cubed gives me negative 8. Negative 3 cubed gives me negative 27. Negative 4 cubed gives me negative 64. So my pattern is negative n to the cube. And when you write your formula, you say a of n, like we did over here, okay, equals negative n cubed. I just translate it into a formula.
That's it. Done.
That's it, okay? That was a simpler one. Let's see what we can do here. Let's go 0, 2, 6, and 12. So when I input 1, I get this out. When I input 2, I get that out. 3, I get this. 4, I get this. So now we have to think a little bit, okay? What do you know is happening here between those numbers? 0, 2, 6, 12. If I do 2 times 3, I get 6. But if I do 6 times 3, I don't get 12, right? Okay.
Well, if you do 2 times 1, you get 2, and then you do 3 times 2, it's 6, and you do 4 times 2, you get 12.
Good. So there's something going on there with that, yes? Beautiful. I like that pattern, okay? So I need to translate that into something else. So when I take 0 times 1, I get 0, correct? Okay? Or wait a second. Sheesh. I got 0. So when I take 1 times 0, I get 0. When I take the number 2 that I plug in times 1, I get 2. When I take the number 3 that I plug in times 2, I get 6. And when I take the number 4 times 3, I get 12, yes? Okay. So, this number, okay, that I have going on, and this number, how do those two numbers relate? This one is what compared to that?
You said that, what are they called? Which numbers?
Okay, how do these numbers compare right here, 1 and 0? How do 2 and 1 compare? How do 3 and 2 compare? How do 4 and 3 compare?
They match the output, or?
No, I wanna know, like, look at those two numbers specifically, and what do you notice pattern-wise between those two numbers? They're each what away from each other?
1.
1.
Oh, 1 away.
So here's what's happening. You have a function or an equation that says a of n equals my number that I'm inputting times that number minus 1. So if I put a 1 in, I get 1 here, right? And what's 1 minus 1?
0.
The 0 that's there. If I put a 2 in and a 2 here, I get 2 times 2 minus 1, which is 1. So that one's a little bit harder to figure out, okay? But you have to start recognizing patterns and picking up on that. Makes it a little bit more complicated. I'm only gonna have us do that tonight, just those simple patterns like that. And on Tuesday, we will talk about summation notation and talk about sigma notation. You know this like fun little thing like this? Have you guys seen this before?
Oh no.
Yeah.
Okay, we're gonna talk about that type of stuff. Okay, let me give you a little work.
Who are they?